Welcome to Lesson 11.1, Radical Expressions and Rational Exponents. We've been studying both rational expressions and we're going to be talking about radical expressions. And there's actually a relationship between the two. And we're going to be looking at that in this chapter 11. So our essential question today is, how are rational exponents related to radicals and roots? So a lot of R words there. Rational, think of a ratio, a fraction. Radical, think of like a square root, cube root, and of course we're talking about roots. So some important terminology, so please write this down in your notes. We call this number or variable the index. So if you see a 3 there, that means a cube root. Typically we don't put a 2. It's kind of understood if there's not a number listed there for the index that it is a 2, meaning a square root. Then we have the exponent. Sometimes there's an exponent, sometimes there's not. If you don't see an exponent, you can always put a 1 in that place. And we call the radicand is that base. In this example, we're calling A. It could be a number or it could be a variable. So please memorize this terminology. All right, so properties for you to be aware of. If we have a number raised to an exponent and taken the nth root of it, now the index always remains tucked into the radical symbol here. However, this exponent can be placed either inside, underneath the radical, or it can be placed outside. So these are equivalent. So here's an example. If we have the cube root of 8 squared, that would be the same thing as the cube root of 64. And the cube root of 64 is 4. Well, let's say I take the cube root of 8 first. Well, the cube root of 8 is 2. Then I raise it to the exponent. Well, I get the same answer of 4. So again, this exponent can, as far as the order of operations, you can square it to start with, or you can take the cube root and then square it. All right, here's where we get to the meat of our lesson. If we have this radical expression, so we've got the index and we have an exponent, this radical expression can actually be rewritten as a rational exponent. So notice that the index, which we're calling n, goes in the denominator of this fraction, and the exponent goes in the top. So we can rewrite, over here is an example, if we have the cube root of 5 to the 4th power, we can actually rewrite that as 5 raised to a fraction, or in this case a rational exponent. The exponent 4 goes in the numerator, the index 3 goes in the denominator. So that's really what you have to memorize, is this part right here. The exponent goes in the numerator, the index goes in the denominator. It's really easy to switch those up. Maybe you can think of it as the exponent is always the high, it's raised, it's usually higher than all the rest, so maybe kind of think of that as the exponent goes in the numerator. Keep in mind that if there is no, so let's do the cube root of 5. If there's no exponent, I can always list a 5 there. So this would equal 5 to the 1/3 power. So over here to the left, just a little diagram here showing how these are all equivalent. So two radical expressions that are equivalent, and then a rational exponent that is equivalent. And you may be going, okay, why do we care that we can go between a radical and a rational? And you're going to see that in the future lessons, that if we can take a radical and rewrite it as a rational exponent, then we can work with this expression because we have exponent properties. We can add these together, we can multiply them, We can do a lot of things that we can't do when they're in radical form. All right, if you've got your book out on page 535, you have all of this put in a nice table for you. So it's showing how you can go from a rational exponent to a radical expression. And it also shows this property here where we can put that exponent of m either underneath the radical symbol or outside the radical symbol. So just below that chart are some examples I want to take a quick look at. If we are asked to simplify negative 125 raised to the 4/3 power, before today you would have been going, can I put that in a calculator? Well, we really don't need to. What we're going to do is actually change that from a rational exponent back into a radical expression, because I see negative 125 and that number kind of sticks with me because I know it's a perfect cube. So the 3 is my index, the 4 is the exponent. Now we're going to put the exponent on the outside because negative 125 is a perfect cube. So I can go ahead and take the cube root of negative 125, which is negative 5, then raise that to the 4th power and get 625. In B, here's another example of just rewriting it. X to the 11/8th power. Well, we can rewrite that, 8 being the index and the exponent being 11, and either of these would be correct. Well, what if we start with a 5th root, a radical expression here, and we want to go and change it to a rational exponent? Well, we would simply change that to 4/5. And here's another example in which this radical expression would change to x raised to the 3/4 power. All right, so let's practice some of these together under example B. The first one we have is 81/16 raised to the 3/4 power. Notice those numbers, 81 and 16. They're perfect squares, but I do not have a 2 as my index. I have a 4. But hopefully that kind of triggers your mind that you can take the 4th root of 81 and the 4th root of 16. So we're going to rewrite this as a radical expression. So my index is going to be a 4, my exponent is a 3. Now the 4th root, and really I want to make sure that you know that that 4 is tucked in there in that radical symbol. The 4th root of 81 is 3, and the 4th root of 16 is 2. Then I can apply my exponent rule. 3 to the 3rd power is 27. 2 to the 3rd power is 8. Looking at the next example, I have variables, so I'm not going to really be able to simplify much here, but we're going to change it from a rational exponent to a radical. So here's my 3, that is my index. My exponent is the 5, so my exponent goes here. Or we could put the exponent on the outside and the index in parentheses. You go ahead and do example C and D. So stop the video, and once you have answered C and D, start the video again and check your answers. All right, let's check your answers to C. If we change that to a rational exponent, we get 6/3. We do need to go ahead and simplify that fraction to an exponent of 2. 11 to the 2nd power is 121. D, changing that to a rational exponent, we get 5/3. All right, for your turn, number 5, I would like for you to answer B and D and then check your answer. So be sure to check your answer for B and D as a quiz question, and also give if you have any specific questions, please list those as well at the end of the video.